Hi guys, in this video we're going to talk about lists in R. And lists are pretty interesting because they can store different data types. Up until now we've looked at vectors in this file, we've looked at matrices in this file, and those objects can only store the same data type. So they can be all numbers or all characters or all logical. And we've seen that when you try to pass in a numeric and a logical into a vector or a matrix, it coerces stuff. But when you use a list, you don't need to worry about that, because if you want to hold characters and numbers at the same time, you could do that. So lists are pretty cool. You want to keep this in mind, is that, well, how do I store characters and logical and numeric? How do I store all that stuff in one object? You can use a list for that. So let's look at a list. You can create a list here, and I'll name my list LST by using the list function and assigning it to that object. So the list function, it takes whatever elements you want to create your list of. In this case, let me just erase this. In this case, I'm going to pass in a number as my first element. I'm going to pass in a character, a name, as my second element. I'm going to pass in a logical value as my third argument. Of my fourth parameter or fourth argument is going to be a complex number. My fifth argument is going to be a vector of numbers, and my sixth argument is going to be a matrix with 2 rows, and it's going to contain the numbers of 1 to 10. So this list has 6 things in it, and they all are different data types and different sizes and things like that. So these are different data types: numeric, logical, or numeric, character, logical, complex, and then we have a vector, and then we have a matrix. So this list is going to hold all that stuff. So let's just run these 2 lines of code and see what it prints out. And down here in the console, you can see what it printed out. It printed out something. It printed out all our data. Here's 100, here's Bob, here's true, here's my complex number, and here's my vector, and then even here's my matrix down here. So it printed out all that data. And what's interesting is to notice how it printed it out. It has this double bracket notation here. We've been working with single bracket notation previously, but now you can see this double bracket with the 1 inside. This is giving you the first element in your list. So here's the first element in your list. And the first element in your list is a vector. Remember, everything in R is a vector of length 1, and that contains the value 100. Here's the second element in your list with the double bracket notation. So when you use lists, you're in the double bracket world. Just remember that. So to access elements in a list, you use the double bracket like this, and it'll print out the second element in your list, and the second element in this case is a vector of length 1, and what's in it is Bob. And here's the third element in your list right there. It's a vector of length 1 that contains the logical value true. The fourth element is a vector of length 1 that contains this complex number 600 plus 5i. The fifth element in your list is a vector of length 4. So this vector has 4 things in it, and four numbers in it. Sorry. And the sixth element in your list is a matrix, actually, of 5 columns and 2 rows. And use the double bracket notation like we just talked about. And now you can see the matrix is there fully with its rows and columns. So how do we use that double bracket notation? Just one time here. If we want to access, say, this true here, all you need to do is put double bracket 3, and when you run this bit of code, here, I'm just going to highlight this line. It's going to say, give me the third element in this list, and the third element is 1, 2, 3, so it should be true. So I'm just going to run this, and sure enough, list with the double bracket notation and 3 gives me true. A couple other things. Look at the dimension and the attributes of a list. So if we run these 2 lines of code, highlight the lines and press Control Enter, the dimension is null and the attributes are null. So by default, the list doesn't have a dimension because it can contain multiple objects. Like we've seen, it can contain a vector here, it can contain a matrix. It doesn't really have its own dimension. It has inner objects that have dimensions, right? The attributes will tell you if there's any names or any other characteristics of this list object. What you can do if you want is name the elements in your list. So here I'm going to put, my number, and this is going to be the name of my first element. So now when I run this bit of code now, look what happens. My attributes of my list has a $sign names, and the first name is my number, and then the other names are blank 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 because I didn't put any other names here. So all this is doing is allowing you to put a name on your elements in your list, and then to reference the name you just do this: list $sign my number. So if I run this code here, oops, it didn't print out, it printed out null here because I put a capital N instead of a small n. If I change that to small n and run it down here, list $sign my number, it gives me 100. If I do the same thing, if I want to put, I can put names on every element here. I'll just do one on the matrix, my matrix. I'm going to put equals, and if I run this code now, I'll put list $sign my matrix. When I run this code, now you could see you can access your matrix in your list by using this dollar notation, which will access, what is it accessing with this dollar notation? It's accessing an attribute here. Remember, names is an attribute of the list object. So that's what you're doing with the dollar notation. Let's do a couple more things before we end the video here. Let's say, so now you know how to set the names attribute of a list object. You can do it like this, and this comes in handy when you have a function. When you write a function and you return multiple things, you could return them in a list and name the elements in your list. So it makes it real easy when you return a list from a function to access the values in your list. That makes it really easy. So you want to remember that you can do this. Now let's look at how we can use the double bracket notation and the single bracket notation right next to each other. So let's say we want to access the first element in my list, and I want to access the first the first element in whatever that element is. So let's say my number is no longer just one number. Now it's going to be a vector that contains two numbers, 103. And let's say I want to access this 3 here. How do I do that? I can just do this. List, give me the first element in the list, and then if that's a vector, which it is, I want to get the second element in that vector. So if we run this code, you'll see down here what this did is gave me the first element in my list, which is that vector 100, 3, and it gave me the second element in that vector, which is 3. So I just was able to access this right here. Similarly, I could do the same thing by, if I copy this, I could do this, my number, oops, I could do my number 2, and if I run this code now, I get the same output, right? So you could see that you could use double bracket notation, or you could put a name, and you could then use the single bracket notation. Either way, it works to access all the elements inside your list. You could do that. If you want to access the matrix, which is the 6th element in the list, you could do it like this, or as we said before, just now, you could do it like this, my matrix, and then you could use double bracket notation to say, give me, here's the matrix. I say, give me the first row, the 4th column. So the first row is, here's the first row, here's the 4th column. It should print out the number 7. I could do that here by doing give me the first row, the fourth column. And when I run this, you get the number 7 here. So this is the first row, fourth column. Let's say you wanted everything in the first row, you could just do this. Just take off, put the comma there with no index of the column, and it'll give you all the columns back. And when you run it now, this is in my matrix, which is the 6th element, give me the first row. And there it is, the first row. There's the first row. Or you could use a name, and you could say, in my list, use the dollar notation. This sort of dollar operator allows you to access the attribute of that list, and give me the first row again, and there's the first row. So that's what I wanted to show you in this video. Lists are very powerful. The main thing to take away from this video is that unlike vectors and matrices, they can contain multiple data types. These are numeric data, this is character data, logical data, complex. Then even bigger than that, even more sophisticated, they can contain vectors, they can contain matrices, and you can access all that information really, really simply with either double bracket and single bracket notation, or you can put a name on each element and then access it with the single bracket notation after the name. So if you have any questions, email me, visit my website, write in, subscribe, let me know what you think.